We're going to perform a parabolic flight. We have two goals today. We're going to test augmented reality glasses, and we're going to do a test to research the behavior of fluids under zero gravity.
Parabolic flights is one option to provide a low gravity testing environment required for research or for development for anything that will later on go in space.
I'm very excited today. I'm also a bit nervous because it's parabolic flight, and I'm very interested in the flight results of the experiment.
I expect a pretty heavy flight because we're going to do a lot of parabolic flights, so I hope I feel well still at the end.
What we're going to do is, when we get up to altitude, we'll accelerate to the maximum level speed of the aircraft, at which time we'll perform a pull-up maneuver where we point the aircraft quite steeply, about 60 degrees nose up, during which period you're actually experiencing higher G levels. And when we reach this attitude, we unload the aircraft and we start a parabolic, hence the name, flight trajectory. And during that trajectory, we're basically making the aircraft fall back to Earth at exactly the same rate as everything inside it, which makes everything, including your experiment inside, experience zero G.
The accuracy of the parabolas is greatly improved with the AR glasses, which is true for zero G, where it is a little bit easier to do it without the glasses because you can have free-floating objects like a pen or a bottle of water to guide you. For Mars and Moon parabolas, you cannot do that without guidance.
The AR glasses are augmented reality, so you can put any kind of symbology on the eyes of the pilot, which they normally cannot see, and they can keep looking outside instead of head down on the displays.
The experiment is about how liquid behaves in space and how it behaves in a storage tank. It's important to verify that the liquid is at the entrance of the vessel, so we assure liquid will enter the cooling loop. These are cooling systems for satellites.
We're flying with the laboratory aircraft. That's the Cessna Citation behind me. It's a multi-purpose platform that we can very flexibly install sensors and equipment in and use it for various kinds of missions.
While it is a jet aircraft with a speed range which allows about 15 to 20 seconds parabolic flight, it is a fairly small aircraft, and it is easy to get your experiment on board, do your experiments, while maintaining the quality of more expensive facilities available.
The whole flight is tailored to you, so you're in complete control of the flight, what and where it happens.
The experiment was effective. We could see what happens in space. We have, of course, to analyze the results, but at first sight we are pretty happy with them.
Today went very well. The display worked, the symbology was good, and the pilots loved the way they could precisely control the parabolic flights. But what we could improve is to also guide them on the longitudinal accelerations.
The citation is available for customers at fairly short notice. For example, the experiment that we have flown today was arranged last week, so typically within a couple of days between contacting NLR or Delft University, you can have your experiment in a parabolic flight if needed.